Okay, so if you have any questions, type them into the text box. So yesterday we finished off section 8.2. Let's start section 8.3. Absolute value equations. And inequalities. So first, recall the absolute value of 5 is 5. The absolute value of negative 5 is also 5. Therefore, if I wanted to solve the equation, the absolute value of x equaling 5, then that would say that x is either equal to positive 5 or negative 5. So let me give you some conditions on how to solve absolute value equations, given this as a guide. So absolute value equations. So suppose that I want to solve the equation absolute value of x is equal to a, and well, I'm going to look at some conditions first. Let's suppose that a is greater than 0. Then, well, the absolute value is either equal to x or it's equal to negative x. Therefore, x is equal to a or negative a. We sometimes use, well, the shorthand notation that I used above, that x is equal to plus or minus a. And that's how I solve a absolute value equation. But suppose that a were 0. Okay, then, or maybe I'll say it this way. So suppose that we were solving the case where a were 0. Then in this case, positive and negative 0 is just the same thing. So the only way that the absolute value could equal 0 is if the value is actually just 0. Next, suppose I wanted to solve absolute value equals a, and suppose that a were less than 0. Well, you can't have an absolute value equaling a negative number, and so in this case, you'd have no solution. So basically, the way you solve an absolute value equation is that the absolute value is just plus or minus, and then you just see if you have a solution or not. Let's do on page 336, let's say problem number 2. So in exercises 1 through 24, solve the equation. So absolute value of x equals 4. So therefore, well, it's just case 1. X is equal to 4 or negative 4. And that is your solution. Let me do problem number 4. The absolute value of x plus 1 equals 1. Well, x plus 1 is either going to equal 1 or negative 1. So let's subtract 1 from both sides of my equation in order to solve for x. And so x is equal to negative 1 plus or minus 1. Well, let's see what that gives us. Well, negative 1 minus 1 is a negative 2. Negative 1 plus 1 is 0. And so x is equal to negative 2 or x is equal to 0. So in this case, you have two solutions, just like what you had above. Let's do problem number 6. Absolute value, x minus 7 plus 2 equals 3. So the first thing that you should do when solving an absolute value equation is to isolate the absolute value. And so let's try to isolate my absolute value. So let me subtract 2 from both sides of my equation. So the absolute value of x minus 7 is equal to 3 minus 2, which is 1. And so now this just says that x minus 7 is equal to plus or minus 1. Well, let's solve for x. So let's add 7 to both sides of my equation. So x is equal to 7 plus or minus 1. And so let's simplify this. So 7 minus 1 is 6. 7 plus 1 is 8. And so x is equal to 6 or x is equal to 8. Let me do problem number 10. Absolute 6 minus 2x plus 3 equals 2. So let's try to solve this equation. So first thing to do is try to isolate the absolute value on one side of my equation. So let's subtract negative 3 from both sides of my equation. So I get here that absolute 6 minus 2x is equal to negative 1, but that's impossible. You can't have the absolute value equaling a negative number. And so this has no solution. There's no way you have the absolute value of some real number. There's no way that you have the absolute value of some real number equaling a negative number. So there's no way that it could equal negative 1. Yes. So if you can sorry about that. Okay. if you can just write it as a plus or minus a number, then you write it as plus or minus a number. However, if you can simplify it, then you simplify. So notice you have a negative 1 plus or minus 1. So then you would need to write it as negative 2 and 0. So if you can simplify it, then you do simplify it. So like the 7 plus or minus 1, you would write that as 6 and 8. So if you can simplify it, you do. Oh, thank you. Okay. is no solution because, right, so um, because I have an absolute value equal -1. There's no way, if you take the absolute value of any number, no matter what number, no matter what real number you take, the absolute value is always going to be a non-negative number. So there's no way you could have that the absolute value of a number is -1. And so that's why it has no solution. Let me do problem number 12. Okay. Absolute value, x plus 5 equals 0. Well, the only way an absolute value can equal 0 is if what is inside the absolute value is 0. So subtract 5 from both sides of your equation. So x is equal to -5. So in this case, there's only one solution. X is equal to -5. Let me do problem number 16. Absolute 1/4 x plus 1/3 equals 2/3. Okay, so I've already isolated the absolute value. And so since I've isolated the absolute value, I know that what's inside, the 1/4 x plus 1/3 is just equal to plus or minus the right-hand side, in this case, 2/3. I want to get rid of the denominator so I can solve this. So why don't I multiply both sides of my equation by 12, the least common denominator, and I'll get rid of all my numerators. 4 divided by 12 is 3 times x is 3x. 12 divided by 3 is 4. Positive times plus or minus, plus or minus. 12 divided by 3 is 4 times 2 is 8. Let me solve for x. So subtract 4 from both sides of my equation. So 3x is equal to a -4 plus or minus 8. Let me divide both sides of my equation by 3. And so x is equal to, the reason I put the plus or minus is because whenever getting rid of the absolute value, so it's the absolute value is equal to 2/3. Therefore, what's inside this stuff here is equal to plus or minus 2/3. Because if you take the absolute value of this, you'll get 2/3. And so what's inside had to be either equal 2/3 or -2/3. So that's why I set what's inside equal to plus or minus 2/3. Okay. So, good. Okay, so x is equal to a -4 plus or minus 8 over 3. So let's simplify that. So x is equal to a -4 minus 8 over 3, which is a -12 over 3, which is -4. Or x is equal to a -4 plus 8 over 3, which is equal to 4 over 3. And so my solution is x is equal to -4 or x is equal to 4/3. And that is the solution to this equation. Any questions about that? Let me do problem number 24. Absolute 9 plus x over 3 is equal to 1. So, what's inside the absolute value? 9 plus x over 3 must equal plus or minus 1. Let me get rid of the denominator. So let me multiply both sides of my equation by 3. 3 times 9 is 27. The 3's cancel, so I get x. Three times plus or minus 1 is plus or minus 3. So let me subtract 27 from both sides of my equation in order to solve for x. So x is equal to a negative 27 plus or minus 3. So x is equal to negative 27 minus 3, negative 30. Negative 27 plus 3, negative 24. And those are my solutions. Any questions about that? Okay, so that's really how to solve these absolute value absolute value equations. Let's start to look at absolute value inequalities. So, let's recall the following. The absolute value is equal to, well, it's equal to x if x is greater than or equal to 0. It's equal to negative x if x is less than 0. Okay. So, if I were going to solve an absolute value inequality, let's say like something like absolute value of x is less than 1, then that would say that, well, absolute value is less than 1 if x were greater than 0, or we would have that x is negative x is less than 1. Okay, if x were less than 0. So I want to solve this. Well, I could rewrite this by just multiplying both sides of my inequality by negative 1, in which case that would just have x is greater than negative 1 and x is less than 1, which just means, well, if I wrote this in the previous form as a three-part inequality, this would just say that x is between 1 and negative 1. So really, the way I would solve these type inequalities is I would just sort of get rid of the absolute value and then put a plus or minus, which is sort of what we did with equations. So let me give you some cases for absolute value inequalities. Okay, so let's try to solve, well, the first case that I was looking at, absolute value of x less than a, and let's suppose that a were greater than 0. Then this would just say that, well, negative x, let's write it this way, that negative x is less than a, and that x is less than a. And so if you multiply by -1, that would just say that x is greater than negative a, and x is less than a, which you could write as, well, negative a is less than x, and x is less than a. And of course, if you wrote this in the three-part inequality, that would just say that a, negative a, is less than x is less than a. And so, to solve absolute value of x less than a, we just have that x is between negative a and positive a. Of course, assuming a here is greater than 0. Now, let's look at this case. Suppose absolute value of x is less than a, and suppose a is less than or equal to 0. Well, you can't have an absolute value that's negative. So therefore, this has no solution. Let's look at the case where I have less than or equal to. So if I have x is less than or equal to a, and suppose that a were greater than 0, well, we could do the same thing we did in the first part, and I'm not going to write down all the intermediate steps, but therefore, absolute value of x is just plus or minus x. And so writing it as a three-part inequality, I just have that a is less than or equal to x, less than or equal to a. Next, suppose I want to solve when the absolute value is less than or equal to 0. Well, it can't be less than 0, therefore it must be equal to 0. And so the only way the absolute value is equal to 0, as we saw above, is when x is, what's inside is actually equal to 0. So let's try to solve absolute value less than or equal to a when a is less than 0. Well, this would say the absolute value is less than 0, but that's impossible. And so this has no solution. Okay, so that's for less than or less than or equal to. Let's look at the case of greater than or equal to. I guess I'll look at the case of greater than first. And so suppose absolute value of x is greater than 0. And let's, uh-oh, let me just check if everything went. Can everyone still hear me? Can everyone still see me? So everyone can still hear me and see me. Good, good. Okay, that's good. Um, and so let's suppose that a were greater than 0. Okay, so it's going to be very similar to what we had from before. So either negative a either negative x is greater than a, or x is greater than a. And let's multiply both sides of my equation by negative 1. And so I get, actually, let me do it the other way. Let me just write it this way because this is the way I usually write it. So x greater than a, or x, or negative x greater than a. And so if I multiply both sides of my equation by negative 1, then the inequality switches. So it becomes x is less than negative a. And unfortunately, we don't have a standard simplifying notation for this, so we'll just have to leave it in this form. Okay. Let me do next one. Let's suppose that a were 0. So in the case where absolute value is greater than 0, well, basically it's going to be everything is greater than 0. The only thing that doesn't have an absolute value greater than 0 is 0. So it's everything except for 0. So all real numbers except for 0. Well, let me do the next one. Suppose I have the absolute value is greater than a negative number. Well, certainly all absolute values are greater than negative numbers. And so x is just all real numbers. Okay, so that's greater than. Let's do greater than or equal to. Well, just like before, in the first part, I could have had x would either equal a, x would either equal positive x or negative x. And so this says that x is greater than or equal to a, or x, or negative x, sorry. Negative x is greater than or equal to a. And so that's what the absolute value is. It's just the absolute value is either going to be plus or minus the value. And so multiplying both sides of my equation by -1, I get here an x. The inequality switches because I multiply it by a negative. And a times -1 is a negative a. And lastly, suppose that a were less than or equal to 0. And so the absolute value is always non-negative. And so certainly it's always greater than or equal to either 0 or a negative number. And so again, this is all real numbers. So I would say that in general, I mean, there are 10 cases. Would I memorize all 10 cases? Probably no. I would just memorize the first case uh, and the the fact that if it's less than, it becomes between, and if it's greater than, and then the sixth case or whatever, and if it's greater than, then it just becomes an or. But everything, so the only difference is between these two cases is that less than is an and, greater than is an or. The product of, if you have positive times negative, uh, it's going to be negative. But if you have, well, the only way you can have the product things to be positive if they're both positive. Okay, so let's do an example. Let's say um, page 330, is that 6 or 7? Oh, it is 336. Yeah, 336. Um, so page 336. Let's do problem number 26. Absolute value of x less than 2. In exercises 25 through 66, solve, and graph the inequality. So let's solve it and graph it. And so I have that the absolute value is less than 2. Therefore, I have that x is between -2 and +2. So this is actually the open interval from -2 to 2. Let's graph this. And so it looks like I'm going from -2 to +2. And so it is everything in between. And so it's just the open interval from -2 to +2. Let me do problem number 30. So just remember that whenever you have a less than or less than or equal to, you can just use that simplifying notation. If we allowed the non-standard notation, you could use also the non-standard notation. Which formula did you use? The very first one. If the absolute value is less, then it is between. So again, you really only have to memorize one formula. Just that one. And then we've got to think about the other special cases. And so that's what I would probably say is that you memorize that one case and then you think about the other cases. Absolute value, x minus 7 minus 2 less than or equal to 6. So let me isolate the absolute value on one side of my inequality. Let me add 2 to both sides of my inequality. So the absolute value of x minus 7 is less than or equal to 8. Therefore, I have that x minus 7 is between negative 8 and positive 8. I want to solve for x, and so I want to isolate x in the middle. It's a three-part inequality. So let me add 7 to all three sides of my inequality. And so negative 8 plus 7 is a negative 1, is less than or equal to x, is less than or equal to, the 7's cancel. 8 plus 7 is 15. And so this is the closed interval from negative 1 to 15. Let's draw this. And so it's from negative 1 to 15. I will include negative 1 and 15 and everything else in between. So I include both the negative 1 and the 15, and I include everything else. Oh, how negative 1? It's 7 minus 8 is negative 1. I just added 7 to every side of my inequality because I wanted to isolate x in the middle. And so 7 minus 8 is negative 1. Okay. Let me do 34. Absolute negative 2x minus 4 is less than 1. And so this says that negative 2x minus 4 is between negative 1 and positive 1. I want to solve for x, so I want to isolate x in the middle. So let me add 4 to all sides of my inequality. And so if I do that, I get 4 minus 1 is 3, is less than negative 2x, is less than 1 plus 4 is 5. Let me divide all sides of my inequality by a negative 2. And so if you recall, if I divide by negative, I've got to do this switching around. So I have to go, instead of from left to right, I've got to go from right to left. So 5 divided by negative 2 is a negative 5 halves. The less than moves from here over to here. The negative 2x divided by negative 2 is just x. The inequality moves, so that's a less than. 3 divided by negative 2 is a negative 3 halves. And so this is the open interval from negative 5 halves to negative 3 halves. And so this is my interval from -5/2 to -3/2. I include everything in between, but I do not include the endpoints. Now, actually, I could have done this slightly differently. So let me do this slightly differently. So, or the absolute value of -2x minus 4 is less than 1. This is the same as -2x plus 4 is less than 1. Because certainly I can factor out the negative. But the absolute value of a product is just the product of the absolute values. So this is the same as the absolute value of -1 times the absolute value of 2x plus 4 is less than 1. But the absolute value of -1 is 1. And so this is just absolute 2x plus 4 is less than 1. So this says that what's inside 2x plus 4 is between 1 and -1. Subtract 4 from both sides of my equation. All sides of my equation. And so I have that -5 is less than 2x is less than -3. Divide by 2. And so I get -5/2 less than x less than -3/2. The same thing that I got from before. So I could actually have gotten rid of all the negatives. But I hesitate to actually do this only because students incorrectly get rid of the negatives. Um, so if you do it correctly, then you're able to do this. But obviously, if you do it incorrectly, then it's wrong. Let me do problem number 36. Any questions about this? Okay, let me do problem number 36. Absolute 2x plus 3 plus 5 less than or equal to 6. Let's first try to isolate x on one side, the absolute value on one side of my equation. So let's subtract 5 from both sides of my equation. So the absolute value of 2x plus 3 is less than or equal to 6 minus 5, which is 1. So therefore, what's inside the absolute value, 2x plus 3, is between -1 and +1. Okay, let me subtract 3 from all sides of my inequality in order to isolate x in the middle. And so, -3 minus 1 is a -4. The 3's cancel, so I get 2x. 1 minus 3 is a -2. Let me divide both sides of my equation, all sides of my equation, by 2 in order to solve for x in the middle. And so I have -2 is less than or equal to x is less than or equal to -1. And so this is the closed interval from -2 to -1. And so this is all numbers. between -2, -1. It includes everything in between, and it includes both -2 and -1. Okay, let me do problem 38. Absolute x plus 1 less than 1/2. So this says that x plus 1 is between -1/2 and +1/2. Let me multiply both sides of my equation. No, there's an x in the middle. Let me not do that. Let me subtract 1 from all sides of my equation in order to solve for x isolate x in the middle. And so -1 minus 1/2 is -3/2. The 1's cancel. 1/2 minus 1 is a -1/2. And so this is the open interval from -3/2 to -1/2. It is all numbers from -3/2 to -1/2. It includes everything in between, but it does not include -3/2 nor -1/2. Let me do problem number 42. So you notice that the less than or equal to's, they're all really the same. Now let's deal with greater than or equal to. And those will also be of the same type, but different than the less thans. And so absolute value of x is greater than or equal to 5. And so I have here that, well, x is greater than or equal to 5, or x is less than or equal to -5. And that's my solution. And so just remembering that greater thans is an or, give me my solution. So this is actually the union of two closed intervals from -infinity to -5 and from 5 to infinity. Let me draw the solution. So this is -5, +5. It will include everything greater than or equal to 5, less than or equal to -5. And that is my solution. Okay. Let me do problem number 46. absolute 3x minus 1 greater than 2. And so that says that 3x minus 1 is greater than 2, or 3x minus 1 is less than negative 2. Well, I guess I'm going to have to solve each of these individually. So let's add 1 to both sides of my equation, of my inequality. And so I get 3x is greater than 3. Divide both sides of my inequality by 3. And so x is greater than 1. Or, let's do the other one. Add 1 to both sides of my inequality. 3x is less than negative 1. Divide by 3. X is less than negative 1/3. And so I have the union of these two open sets from negative 1/3, well, from negative infinity to negative 1/3, and from 1 to infinity. And so I have negative 1/3, 1. So I have these. Two intervals, open intervals. So I have from 1 to infinity. So I have x's are greater than 1, and I have x's are less than negative 1/3. And it is the union of these two intervals. Oh, well, look at the arrow. This arrow here is greater than 1. So notice this arrow points in this direction. Notice this arrow points in this other direction. Okay? Whereas before, so notice this arrow here points in this direction from the 5, and this points in this direction from the negative. Next, this is a, well, here, let's do a less than. Okay, so it points, it goes in this direction. And this is, well, I wrote it, notice the x is greater, it's written in the wrong direction. So for this side, it's pointing that way, and it's the intersection, so it's the overlap between those 2 points, those 2 directions, which is just this overlap. Yeah, so notice that for the less than, that's when you get these, like, it's an and, it's an overlap. Whereas the greater than, that's when you get the union. Okay. It's a combination of the intervals. That was 46. Let me do problem number 48. Absolute 5x plus 7 greater than 0. So this is one of the special cases. So now you have to think to yourself, okay, An absolute value is greater than 0. And so, well, every absolute value is going to be greater than 0. The only time it's not greater than 0 when it's equal to 0. So it should be everything except when what's inside the absolute value is 0. So it's everything except for 0. Let's solve for x. Subtract 7. And so 5x is not equal to negative 7. Divide by 5. And so x is everything except for negative 7 halves. It is the union of negative infinity to negative 7 halves with negative 7 halves to positive infinity. It's everything except for this one point, negative 7 halves. It is everything except for negative 7/5. So it is, oops, all of this so it's everything except for that one little point. Because at that one little point, negative 7/5, that's when you are taking the absolute value of 0, which is 0. So, but everything else that you plug in will work. So the only thing that doesn't work is just this one little point. Any questions about that? Okay, let me do problem number 52. Absolute 2x over 3 minus 1/2 greater than or equal to 5/2. So this says that, well, 2x over 3 minus 1/2 is greater than or equal to 5/2, or 2x over 3 minus 1/2 is less than or equal to negative 5/2. Let's solve each of these equations, inequalities, separately. So let me multiply both sides of this inequality by the least common denominator, 6. 6 divided by 3 is 2 times 2x is 4x. 6 divided by 2 is 3 times 1 is 3. 6 divided by 2 is 3 times 5 is 15. Let me add 3 to both sides of my inequality. And so 4x is greater than or equal to 18. Let me divide both sides of my inequality by 4. The 4's cancel, so I have x is greater than or equal to. I can rewrite 18 fourths as well. I can divide both 18 and 4 by 2, so 9/2. Or let's solve this other inequality. So let me multiply both sides of this inequality by the least common denominator, 6 again. 6 divided by 3 is 2 times 2x is 4x. 6 divided by 2 is 3 times 1 is 3. 6 divided by 2 is 3 times negative 5 is negative 15. Let me add 3 to both sides of my inequality in order to isolate x on one side of my inequality. So 4x is less than or equal to negative 12. Divide both sides of my inequality by 4. So x is less than or equal to negative 3. So this is the union of the closed interval, negative infinity to negative 3, with the closed interval from 9/2 to infinity. Let's graph this. So I'll put here negative 3, 9/2. So we'll include negative 3, positive 9/2, and everything in between. From negative 9/2 to infinity, and from negative 3 to negative infinity. Why infinity? Well, if you look here, if I take numbers, well, let's just look here at the graph. As a matter of fact, you can look at it. Where does this interval go? Well, it goes from positive 9 halves, and it keeps going for x is greater than it. Well, if you go for x is greater than 9/2, well, that includes 5, 6, 7, 8, 9, 10, all the way out to infinity. And I'm taking x is less than negative 3, so that would be less than or equal to negative 3. That'd be negative 3, negative 4, negative 5, negative 6, negative 7, all the way out to negative infinity. So it goes from negative infinity to negative 3, from 9/2 all the way out to infinity. So if you look actually at the graph here, you can see that it goes from negative infinity to negative 3, from 9/2 to infinity. Because, well, x's are always less than or equal to negative 3. X's are always greater than or equal to 9/2. Okay. Let me do problem number 56. Two x over 7 minus 1/2 in absolute value greater than or equal to 9/2. And so let me get rid of the absolute value. So I have that 2x over 7 minus 1/2 is greater than or equal to 9/2, or 2x over 7 minus 1/2 is greater than or equal to, less than or equal to, negative 9/2. Let me solve each of these inequalities separately. So let me get rid of the fractions. Actually, it'd be easier to just add 9/2 and a half to get 5, but let me assume that I don't see that. Let me multiply both sides of my equation by 14, the least common denominator. 14 divided by 7 is 2 times 2x is 4x. 14 divided by 2 is 7 times negative 1 is negative 7. It's greater than or equal to, because I'm multiplying by positive constant. 14 divided by 2 is 7 times 9 is 63. Let me isolate x on one side of my inequality. So let me add 7 to both sides of my inequality. And so 4x is greater than or equal to 70. Let me divide both sides of my equation by 4. Both sides of my inequality by 4. And so x is greater than or equal to 70 over 4. Well, I can divide both 70 and 4 by 2. So 35 over 2. Or let me multiply both sides of my inequality by the least common denominator, 14. 14 divided by 7 is 2. Times 2x is 4x. 14 divided by 2 is 7 times negative 1 is negative 7. 14 divided by 2 is 7 times negative 9 is negative 63. Let me add 7 to both sides of my inequality. And so 4x is less than or equal to a negative 56. Let me divide both sides of my inequality by 4. And so x is less than or equal to negative 56 divided by 4, negative 14. And so this is the closed interval from negative infinity to negative 14, union the closed interval from 35 halves to infinity. Let's draw this. And so I have here negative 14, 35 halves, and so it goes from negative infinity to negative 14, 35 halves to infinity. It includes negative 14 and everything below. It includes 35 halves and everything above. Let me do problem number 60. X minus 2 in absolute value plus 3 is less than 4. Let me subtract 3 from both sides of my inequality. And so x minus 2 in absolute value is less than 1. Let me rewrite this. Well, this is the same as saying that x minus 2 is between negative 1 and positive 1. Let's solve for x. Isolate x in the middle. Let's add 2 to every side of my inequality. And so 2 minus 1 is 1. The 2's cancel. 1 plus 2 is 3. So this is the open interval from 1 to 3. It includes all numbers between 1 and 3. but it does not include 1, nor does it include 3. Let me do problem number 64. Absolute 2 minus 3x greater than or equal to 5. And so I have that 2 minus 3x is greater than or equal to 5, or 2 minus 3x is less than or equal to negative 5. Let's subtract 2 from both sides of my inequality. So negative 3x is greater than or equal to 3. Let me divide both sides of my inequality by negative 3. But if I divide by negative 3, I'm going to have to switch the inequality to a less than or equal to. Positive 3 divided by negative 3 is a negative 1. Now let's solve the next inequality. Let's subtract 2 from both sides of my inequality. So negative 3x is less than or equal to negative 7. Divide both sides of my inequality by negative 3. Negative 3x divided by negative 3 is just x. Again, I'm divided by negative, so I'll switch my inequality to greater than or equal to. Negative divided by negative is positive 7/3. So this is the union of the closed interval from negative infinity to negative 1 and from 7/3 to infinity. It is from negative 1 to 7/3. So it includes negative 1. It includes 7/3. Everything above 7/3. Everything below negative 1. And that is your answer. Let me do problem number 66. Absolute 7 minus 2x less than or equal to less than or equal to 1. And so this says that 7 minus 2x is between negative 1 and positive 1. Let me try to isolate x in the middle. So let me subtract 7 from each side of this inequality. Negative 1 minus 7 is a negative 8. The negative 7's cancel. The 7's cancel. So I get a negative 2x. 1 minus 7 is negative 6. I could divide all sides of my inequality by negative 2. But when I do that, I'm going to have to read everything in reverse. Negative 6 divided by negative 2 is a positive 3. I'll bring the inequality over to this side. Negative 2x divided by x. Negative 2x divided by negative 2 is x. I'll bring this inequality and write it over here. Negative 8 divided by negative 2 is a positive 4. And so this is the closed interval from 3 to 4. So I have my closed interval from 3 to 4. I include 3. I include 4. And I include everything in between. Note, maybe I'll do this a slightly different way. So, any questions about this? Okay, so let me say, or let me do it a slightly different way. Absolute 7 minus 2x less than or equal to 1. Okay, so this is the same as if I factor out a negative sign, a negative 7 plus 2x. So just factor out the negative sign. And like before, the absolute value of negative 1 is just 1. And so this is just absolute value of negative 7 plus 2x less than or equal to 1. So this just says that negative 7 plus 2x is between negative 1 and positive 1 at 7. So I get 7 minus 1 is 6. 7's cancel. 7 plus 1 is 8. Divide by 2. And so you get x is between 3 and 4. Just like what I got above. So if you do it correctly, you could have gotten rid of the negative in front of the x, but you know you have to do it correctly. Okay, so that really finishes off section 8.3, which actually finishes off chapter 8. And seeing that I have 2 minutes, I guess that will be it for today. So tomorrow we will start chapter 9. So I'll see you tomorrow at 11, unless there are other questions. Okay. Hmm.